come across this type of problem in your examination, you always run away. Is that how to do things? You even skip this one during your test. Well, that in this place you are given the mole. Okay, so let this one represent your mole air. Mole is usually in what? In N. Okay, and you are given this one as your temperature. So let this one be the temperature 1 there, that is inertial temperature, and you are given this one as your pressure in Pascal. Okay, so let this one here be your pressure 1. Okay, occupies this one as a volume. You can see this one in meter cube. So let this one here represent your what? Your V1. Okay, so the questioner asks you to calculate what? Calculate the work done on the gas, which is expected to be negative. Now again, you have to calculate the heat absorbed. The heat absorbed, because it absorbed it, it is expected to be positive. Now under the following condition, what are the conditions again? So you are given that the final volume and the final pressure is given to be, let this one be your what? Your V2. Let this one be your what? Your P2. Now in order to solve this problem, so the first one says under the condition of isothermal reversible the condition of isothermal reversible. So what does that mean? That means the temperature is kept constant. I get my point now, and it is a reversible process. Why is it reversible? Because of change in what we call volume. So which formula are you using here? Note that for heat absorbed, that is Q for heat absorbed, which is for reversible condition. Reversible condition is equivalent to what we call the work done under what we call reversible condition as well. So how do you now calculate your work done? To calculate work done is equal to, that is 2.303 nRT followed by what we call log V1 over what? Over V2. That is the formula you are expected to use there. Okay, so with this formula, all those parameters that I've mentioned the other time, you begins to what? You begins to fix them in. So from what you have here now, your work done, which is W, equals to 2.303 times N, which is the numbers of moles, is given from the question to be 100. When you convert this one to what? To ordinary form. Now, R in this place, R is always what you call the 8.314. So 8.314. Then multiply by the temperature that you are given, which is your T1. This one is 300. So that is 300. Then multiply by log. The log of what? Of V1. What is the value of your volume 1? This is given here to be 0.0416 over the value of your V2. What is the volume of V2 given to you? 0.8 followed by 32. Now come to the next step. What are you to do here? So you have to multiply all of them in this place together. So that will be 2.303 times 100 times 8.314 times 300 times. Now when you use this one to divide this, mathematics says that it will give you log of 0.05. Okay, so what will now be the value of log of 0.05 now? That will be work done equals to 2.303 times 100 times 8.314 times 300 times log of this one here. The log of this one is expected to be minus 1.3010. If you now multiply all of them together, what should be the final value you should obtain there? The final value you should obtain for this should be minus 7.47 times 10 raised to the power 5 joules. That is the final value you should obtain there. For the what? The question asks you to calculate the work done. So if work done is equivalent to this one here, under what we call isothermal reversible condition, then what will now be the what? The heat absorbed. Take note, this one is negative. So the heat absorbed, which is Q reversible, take note, heat absorbed, which is the second one. This is the first one. This one here is second one, should be equals to plus 7.47 times 10 raised to power 5 joules. That is what you have to calculate. So anytime you come across the problem now, you should know how to solve the problem. As simple as that. It's not hard at all. It's not hard, as you can see. So we have just solved the first problem now, which is isothermal reversible condition. So let us solve the second reversible condition. So we are going to make use of this formula. Remember, irreversible condition rather. So for this irreversible condition, that means it is not reversible. So when it is not reversible, what happened? That means our work done, okay, our work done is equal to, that is minus the what? The pressure, the external pressure, take note of that, followed by what we call the change in volume, okay, change in volume. So in this place, our work done equals to minus the external pressure, okay, given in this problem solving here, which is the final one is going to be 3 times 10 raised to power 5 Pascal. That is the one you are going to use for it. Multiply by change in the volume. So the change in the volume will be the difference of your V1 and your V2, which has to do with the value of your V2. The value of your V2 now is 832 minus the value of your V1, which is 0.0416. Now, if you do this, minus 3 times 10 raised to power 5 multiplied by difference in these two values. The difference in these two values will give you 0.7904. Okay, so the next thing, use this one to multiply this one here. What would that give you? That will give you negative 2.37 times 10 raised to power 5 joules. That is the value that it will give you. So the work done now for the what? For the irreversible, that is what we have here. Now, if that is the work done, don't forget that is what we call the B Roman figure 1. Okay, so for the Roman figure 2, B Roman figure 2 now, number 2, that means we are going to have heat absorbed, which is for irreversible as well, will be positive of this value. That is 2.37 times 10 raised to power 5 joules. That is what the question asks you to calculate. So now, whenever you come across this problem, I want to believe you'll be able to solve it on your own without any problem. Always remember that the work done is equivalent to the what? Equivalent to the heat absorbed. It's only that the work done on the gas is negative, while heat absorbed is always positive. As simple as that for both reversible and irreversible process. Hit the subscribe button, okay? Subscribe on my YouTube channel, follow me on Facebook, comment, like, and share for more. You are doing well and you can do better.